Do you remember when you were a child and you'd leave your toys out in the rain and then you go to get them the next morning and they'd be covered in this brown, crusty substance? Rust. Rust is a reaction that chemically changes the properties of a metal. When I was younger, I was always interested in the rusting process. And now that I'm a chemical engineering major, I better understand the reactions that occur behind it. So using my knowledge, I will help explain rusting a little more and ways to deal with it. So to begin, we'll go over the materials needed for rust to occur. Then we'll move on to the reactions behind the rusting process, and we'll finish by discussing ways to both prevent and get rid of rust. So to start, we'll discuss some of the materials needed for rusting to occur. Not every metal is able to rust. According to Daniel Harris, the chemist who wrote the Quantitative Chemical Analysis 2016 textbook, he explains on page 307 that rust is an oxidizing reaction, so it needs a metal that can become oxidized. Iron is really the only metal that meets both this definition and all of the other qualifications needed for rust to occur. Rust also can't occur on a metal that's already been oxidized because this creates a barrier between the reagents and the metal itself. Both water and oxygen are needed for rust to occur. However, adding an acid or salt to the solution will increase the rate of reaction because it decreases the pH of the solution. To demonstrate, right before this presentation, I put together a solution of water, a weak acid, and some salt, and I placed a stripped bobby pin into it. When I first placed in the bobby pin, it was completely silver, but now you can see that the rusting reaction is starting to take place because it's getting some brown on the side. So now that we've discussed some of the materials needed for rusting to occur, we can move on to the chemical reactions behind the process. All of the chemical reactions here are taken from the Wiley College webpage devoted to interactive concepts in biochem. So first, we start with the redox reaction, in which oxygen is reduced and iron is oxidized. Once we meet these qualifications, we're able to move on to the acid-base reactions, which brings us to the ferric hydroxide. Once we make ferric hydroxide, we can move down to our dehydration equilibria. So we dehydrate 3 times until we get to our Fe2O3. And this is the chemical compound of rust. So now that we have discussed the chemical reactions behind the rusting process, let's finish by discussing ways to both prevent and get rid of rust after it's occurred. One of the best ways to prevent rust is by using coatings such as paint and varnishes. What coatings do is they provide a barrier that keeps the water and oxygen away from the iron, so that way it's not able to rust. Another good preventative strategy is making an iron alloy. An alloy is when you mix another metal into the irons, that way it changes the properties and makes them more resistant to rust. If you already have a substance that's rusted, the best way to get rid of the rust is by removing it with organic acids such as citric acid or vinegar. A USCB scientist explains from the USCB Science line, explains on January 29th, 2009, that the reason that these organic acids work to remove rust is that they turn the compound back into the oxide form, and once it's in that form, it's able to just be easily washed with water and removed. Today, we shone a light on rust. We first went over the materials needed for rust to occur. Then we delved deeper into the chemical reactions behind the rusting process. And finally, we finished by discussing ways to both prevent and get rid of rust after it's occurred. So while rust is a nuisance that most of us have to deal with throughout our lives, next time you come across rust, before you get rid of it, just think for a second about all of the conditions and the equations that needed to be met and occurred in order for this substance to change into another.